You know, when we talk about electric cars, it's always about power, range, and efficiency. But what if the most important piece of tech for all three of those things is something you can't even see? Today, we're pulling back the curtain on the secret life of an EV battery and the invisible bodyguard that keeps the whole thing from, well, melting down. Let's get into it. So, at the center of this whole revolution, you've got the lithium ion battery. These things are the gold standard in EVs, and for a really good reason. They can pack a ridiculous amount of energy into a pretty small space, and they're incredibly efficient at getting that power to the wheels. I mean, they're literally the heart of a modern EV. But just like any top-tier athlete, this powerful heart has a secret weakness, a really critical vulnerability that, if you don't keep an eye on it, can absolutely cripple its performance and even lead to total, catastrophic failure. And this is it. This super narrow temperature band, we're talking between 20 and 40 degrees Celsius. That's about 68 to 104 Fahrenheit. This is the battery's happy place. We're going to call it the Goldilocks zone. Not too hot, not too cold, just right. The entire car is basically designed around keeping the battery in this exact zone. So what happens when it wanders outside? Well, that's when things get pretty sketchy. Because straying from that Goldilocks zone isn't some small problem. It's a direct threat to the battery's health, its performance, and yeah, its safety. And it doesn't matter if it's too cold or way too hot, the consequences are bad news. Your car's performance can just plummet, your efficiency tanks, and the overall lifespan of that very expensive battery pack, it gets shorter. But the biggest worry, especially when things get hot, is the massive safety risk. And that risk? It has a pretty scary name. Thermal runaway. The best way to think about it is as a point of no return for a battery cell. It's this vicious cycle where heat just creates more heat, which creates more heat, until you have a complete and unstoppable meltdown of that cell. So, how does this even happen? Well, it all starts with a little overheating, maybe from some damage or from overcharging. That first bit of heat kicks off chemical reactions inside the cell that, you guessed it, release even more heat. And that creates this insane feedback loop, this chain reaction that just spirals out of control until the cell basically cooks itself from the inside out. And listen, this is not just some theory. The research puts it bluntly. When a battery gets too hot, you're not just looking at a bit of damage. You're looking at the real possibility of fire and even explosions. So the bottom line is, controlling the temperature isn't just about performance. It is absolutely about preventing a disaster. So how on earth do car makers stop this from happening? Well, they hire a bodyguard. Meet the Battery Thermal Management System, or BTMS for short. This is the unsung hero of your EV, working 24/7 to keep that battery safe and sound. Now, this bodyguard has two absolutely critical missions. Mission number one, keep the entire battery pack smack in the middle of that 20 to 40 degree Goldilocks zone. Mission number two, and this is just as important, is to keep the temperature uniform across all the little cells in the pack. If you get more than a 5-degree difference between cells, it creates these imbalances that just chew up the battery over time. All right, so how does this bodyguard actually do its job? When you need to keep a battery cool, engineers really have two main playbooks they can run. On one hand, you've got air cooling. It's pretty straightforward, it's cheaper, and it basically just uses fans to blow air across the battery to whisk away heat. Then you have liquid cooling. Now, this is a much more complex system that pumps a special coolant through pipes and plates that touch the battery, pulling heat away way more aggressively. The easiest way to think about air cooling is to picture the fan inside your computer. For just browsing the web, it's totally fine, but the second you start gaming or editing a big video file, that little fan can get overwhelmed fast. Liquid cooling, on the other hand, is a whole different animal. It's much more like the radiator in a regular gas-powered car. It's a heavy-duty, closed-loop system that's built from the ground up to deal with huge amounts of heat and keep a high-performance machine running at its best. So, the big question: which one is better for a powerful EV? Well, to figure that out, researchers ran a bunch of simulations, pitting these two systems head-to-head. It is time for a showdown. Okay, here's scenario number one. Let's imagine it's a warm day, about 32 Celsius, so around 90 degrees Fahrenheit. The question is, how hard can you really push an EV that only has air cooling before that battery starts to overheat? And the results are pretty stark. Now, you'll see something called C rate on the chart. Don't worry about the term, just think of it as performance. So on a nice, mild day, air cooling does okay. But on that warm day, yikes. Performance just falls off a cliff. The system just can't get rid of the heat fast enough. So what's the takeaway here? It means with air cooling, the weather literally decides how powerful your car is. Thinking about full throttle acceleration or a quick charge on a hot summer day? Forget about it. The system just can't take the heat. All right, round 2. Same exact test, same hot 32-degree day. But this time, the battery has a proper liquid cooling system on its side. How does it do? Whoa. Okay, now that is a night and day difference. Remember, the high bar means high performance. It doesn't matter if it's a mild day or a hot one. The liquid cooling system keeps that battery perfectly happy, letting it deliver max power all the time. The weather outside, it barely even makes a dent. So yeah, the winner here is not even close. For any modern high-performance EV that needs to give you consistent power and charge up super fast, a liquid cooling system isn't some luxury add-on. It's an absolute necessity. Okay, so this engineering is fascinating, but why should you, the driver, actually care about this? How does this invisible technology actually affect your day-to-day life with an EV? Well, a great BTMS, and that almost always means a liquid-cooled one, is the reason you can use those crazy fast DC chargers. It's the reason you get that awesome, consistent punch of acceleration in any season. But keeping the battery in that Goldilocks zone, it's also what helps your expensive battery pack last for a long, long time. And most importantly, it's your #1 safety net against thermal runaway. So the next time you plug in your EV or feel that instant torque kick in, just take a second to remember that silent, powerful bodyguard under the floor, working tirelessly to keep everything cool. And it leaves you with a really interesting question. As batteries get even more powerful and charge even faster, what are their next generation bodyguards going to look like?